In this video, I will go over the multiple choice part of your final review. Keep in mind as we go through these questions, these are multiple choice, so you just have to arrive at the correct answer. Okay, so end behavior we looked at in the free response video. Here we're going to look at the degree and the leading coefficient. So if we have an odd degree with a negative, the graph is going to look something like this. Okay, so for end behavior, it's always the limit as x goes to infinity and the limit as x goes to negative infinity. So for this one, as we go to infinity, our graph is decreasing, so it's going to negative infinity. As we go to negative infinity, it is going to infinity. This one is an even, don't be tricked, the even is at the end here, even positive. So that graph will look like that. So again, always the limit as x goes to infinity and negative infinity. Then we fill it in for the particular problem. So this, in both cases, is going to infinity. All right, our next one. You do need to know what these our basic graphs look like. This is going to be a parabola. That's moved to the right 3 and down 1. So the vertex is going to be here. Okay, and those rules are probably something, if you're not confident on, that you'd put on your formula sheet, all the different transformations. So we're going to describe the end behavior again. So just like the last one, as we go to infinity, our graph is going to infinity. As we go to negative infinity, we're going to infinity. Increasing and decreasing, we talked about with our free response question. So it's decreasing to here, then increasing. And people will be tempted to say it's always increasing because both those arrows are going up. But you're always reading the graph like you'd read a book. You're going from left to right, so it means you're going down, then you're going up. So it's increasing when x is greater than negative 3. It's decreasing when x is less than negative 3. Again, remember these are multiple choice, so you have to arrive at the right answer. And the critical point, there's just this 1 at negative 3, negative 1, which is an absolute minimum. Next, we're going to talk about functions being odd or even. So let's remind you of what that is. For the purposes of the final, if you know that an even function is symmetric to the y-axis and an odd function is symmetric to the origin, that's what we're looking for. An even function, f of negative x equals f of x. On an odd function, f of negative x equals negative f of x. So looking at our problems here, the point negative 2, negative 7 is on an odd function. Name another point that must be on the graph. Well, if we have negative 2, negative 7, then across the origin, we're going to have one at 7 in the y and 2 in the x, so 2, 7. The function x to the 4th minus 3 is symmetric about the y-axis, right? Because if we were to graph this, it would just be moved down 3, which means it is an even function. So if we want to complete the graph, again, this will be free or multiple choice, so you just have to find the right answer. Even is going to be symmetric to the y-axis. Odd is going to be symmetric to the origin. So if you flip it upside down, it's going to look the same. All right. Next, we're looking at families of functions and the different transformations that can occur. So in your family of function notes, you have this chart the big ones that you'll want to know for the final, if you have a negative out front, it reflects it in the x-axis. A negative on the inside reflects it in the y-axis, like if you have an e to the negative x. Okay, the translations. If it's on the outside, it affects it vertically. So it's either going to go plus means up, minus means down. If it's on the inside, it moves it left and right. If it's a plus, counterintuitively, it goes left. If it's a minus, it goes right. And then if it's a multiplication, it's a dilation. It's going to stretch or compress. So if it's on the outside, if it's bigger than 1, it stretches it vertically. Between 0 and 1, compresses it vertically. And you can think about amplitude. If you've got an amplitude of 2 versus an amplitude of 1/2. On the inside, it's horizontally. And again, you can think about period on a sine function. So if it's bigger than 1, it compresses it horizontally. If it's between 0 and 1, it stretches the graph horizontally. In addition to knowing those rules, you also need to know the various parent functions that we did. Okay, so the graphic relationship, so our parent function's x squared. We have a -2 on the inside and a +3 on the outside. So on the inside, that's going to move it right 2. On the outside, it's going to move it up 3. Okay, then we have these different graphs. Now, again, keeping in mind that this is going to be multiple choice, so you just have to arrive at the right answer. So the absolute value function is our v. This is going to reflect it over the x-axis, and then that's going to move it to the right the left 2 units. So it's our v, but it's going to be going down. Okay, and you can plug in points. If I plug in 0, we get -2. If I plug in -2, we get 0, and so on. This one's going to go to the right 2 and up 3. And it's going to open up. Okay, but again, this is going to be multiple choice, so you just need to understand which is going to be the correct option when presented with various graphs. Okay, the square root function. Okay, I'll go ahead and draw the parent graph for that one just to show you. 0, 0, 1, 1, 4, 2. That's the parent. This is going to be reflected over the y-axis and then moved up 2. So it's going to be moved up 2, and then it's going to go down instead. That's kind of tough to see. This one is going to be moved to the left 3 and down 4. Okay, so we're going to determine the inverse function if it exists, because we're looking for a function. So if I graph each of these, just as a sketch, okay, this one's going to be a line. This one's going to be a parabola moved right. This one's going to be a square root, like that. So in order for it to be a function, it needs to pass a horizontal line test. So the only ones that do that, this one does, this one does, this one does not have an inverse function. To find the inverse function, we'll switch x and y and solve for y. So x minus 3 equals 2y. So my inverse is going to be x minus 3 over 2. And that might be presented as 1/2 x minus 3/2. Again, you just have to arrive at the right answer. X equals 3 root y minus 2. X plus 2 equals 3 root y. X plus 2 over 3 equals the square root of y. So our inverse will be x plus 2 over 3 squared. All right, I went over the rules for these types of problems in the free response portion of the video. So first thing we need to do is factor to see if there's any points of discontinuity. So this is going to be 2x plus 3 and x plus 1 gives me 2x squared plus 2 plus 3 gives me 5. So this has a point of discontinuity when x is -1. Remove it, plug -1 into what is left, so -2 plus 3 gives me 1. It is no longer rational, so it doesn't have any horizontal, vertical, or slant asymptotes. This one here, this cannot factor to any of these, so there's no point of discontinuity. Okay, the vertical, or anything that makes the denominator 0, so that's x equals 1, x equals -1, and x equals -5. That makes each one of those factors 0. For horizontal, we're looking at the limit as we go to infinity. So if I were to multiply this all through, it would be a cubic function with a leading coefficient of 1. So we'd have a degree 3 over degree 3, which means we have a horizontal at y equals 1 over 1, which is 1, which means we have no slant asymptote. Discontinuity. Point discontinuity just means that a single location, we have a hole in the graph. Infinite means we have some sort of asymptote. Jump means we're going to have some sort of jump in the graph. The next set of questions talk about the continuity test. The continuity test, 3 conditions need to be met. At C, f of C must exist. There must be a function value, so there's no asymptotes or points of discontinuity. The limit as you approach C has to exist, so for both the right and the left-hand sides, it's got to go to the same. And what you get for part 1 and part 2 have to be the same thing. So this is something that you could, again, put on your formula sheet. Okay, so we're going to look and see if these are continuous. So first we look at, is there a function value? And again, remember, this is going to be multiple choice, so the amount of work you show is really up to you. So if I plug -4 in, we plug it into here. That's going to be 3 times -4 plus 5, which is -7, 12 plus 5, yep. So it has a function value, it passes the first part. The limit, as we go to -4, I want to look at the limit of each of these. So 3x plus 5, well, we already did that. And then the limit as x goes to -4 of -x plus 2. So that would be -4 plus 2. So that would be +4 plus 2, which is 6. So this is discontinuous. Okay, and the reason is because the limit as x goes to -4 does not exist. So if you're looking for a multiple choice answer, this is the correct justification. This one, f of 1, is 2 times 1 plus 1, which is 3. Okay, the limit as x goes to 1 of 2x plus 1 is still 3. Then this one, 4 minus x squared, we plug 1 into there and get 3. So the function value exists, the limit value exists, and they are the same thing. So this one is continuous. Okay, this next one, if I try to plug in 2, we get 6 over 0. So this one is discontinuous because f of 2 does not exist. It's a discontinuity. All right, then we have a whole bunch of limits here. So different things. So understanding the difference between whether we're going to a value, like here, or whether you're going to infinity. This first one, you just have a value. So you want to plug it in. So 3 squared plus 2 times 3 minus 4. So that's 9 plus 6 is 15 minus 4 is 11. Okay, these next three, we're all going to infinity. And in the free response video, I went through those rules. This one, if I multiply this out, is this. The degree is the same on the top and the bottom. So it's going to be the ratio of the leading coefficients, which is -2. Okay, here my degree is bigger on the bottom. So this limit is 0. That denominator is going to grow much quicker. Here my degree is bigger on the top, which means it's going to go to infinity or does not exist. Either of those are acceptable. Again, you just have to match the correct answer. Okay, these next three we're going to evaluate. So you want to try plugging it in if you can. So if I plug it in here, we're going to get 9 minus 9 over 6, which is 0 over 6, which is just 0. That is not undefined. That is 0. Here, if I try to plug in then, I'm going to have 9 minus 9 over 3 minus 3, which is 0 over 0, which is not 0. It's not undefined. It needs more work. The work is factoring. So those cancel. So we're left with the limit as x goes to 3 of x plus 3, which is 3 plus 3, which is 6. In this case, I get 6 over 0. So let's see what happens in this case if I try to factor. Okay, so we can reduce this. Okay, but if I still try to plug in 3, it is still 1 over 0, which is undefined. So this limit does not exist. Okay, looking at a limit numerically. Okay, look at these. We're looking at x goes to 2 from the negative side, from the positive side, and the limit. So first thing, I don't care what's happening at 2. Okay, we're looking at what the y values are doing. As x goes to 2, what is y? From the lower side, these values are approaching 3. These values are getting smaller and smaller, going to 0. So this limit does not exist. A common mistake is to say that it's 2 because you're looking at the x values, not the y values. Okay, then we have limits graphically. So first we're going to -1. From the left side goes to 1. From the right side goes to 1, which means the limit exists and is 1. As we go to 2, from the negative side, it approaches a y value of 2. From the positive side, we have a y value of 1, which means this limit does not exist. Graphically, if there's a big jump like that, the limit doesn't exist. Okay. G says, is the function above continuous at the given point? If not, use our definition that we talked about earlier to determine why not. At x equals 2, not continuous. Okay, because the limit as x approaches 2 of f of x does not exist. It has a function value, so it passes the first part, but the limit doesn't exist. At x equals -1, function value exists, limit exists, they're the same. This one is continuous. Next up, in Unit 3, we dealt with exponential functions and logarithmic functions, and we found various different ways to solve equations. This is on the no calculator part, so your answers will be as far as you can go without actually typing it into the calculator. Right, so this one, I'm going to go ahead and subtract x to the 3/4, so I'll have 9x to the 3/4, and then add 5, so that's going to be 144. If I divide that by 9, that'll be 16. So then to get rid of this, we're not using logarithms or anything. I just raise it to the reciprocal power. So this would be 16 to the 4/3, because if I raise this to the 4/3, it goes away. Okay, here, a good thing to know is the relationship between the exponential form and the logarithmic form. So the base of the exponent is the base of the log, and then essentially they switch. So it's log base b of y equals the exponent goes by itself. So for this one, this is the same as 3 squared equals x, which means x equals 9. Okay, in a problem where the variable is in the exponent, we need to use logs. So I'm going to take the natural log of both sides, which we know makes this side just negative 4x. So x equals the natural log of 3.5 over negative 4. And that's how the multiple choice answers will look. 24 is similar with an extra step of dividing by 6. And if you're worried about these computations, I'll have a panic calculator for you. So 150 divided by 6 is 25. Then we'll take the natural log, then divide. So t is the natural log of 25 over 0.047. Okay, this next one, we're going to use the fact that 8 is 2 raised to the 3. So I'm going to rewrite this side as 2 cubed 4x minus 5 equals 2 to x plus 15. So if these two bases are the same, then these two equations must be equal to each other. So I'll distribute the 3. Okay, and then we just have a simple equation. So subtract 2x, add 15, so x is 3. Okay, the other thing you need to know are the rules for logs. Okay, so these rules, again, you may absolutely put on your formula sheet. The product rule, if you have the log of a product, that's the same as log base b of n plus log base b of n. The log of a quotient is log base b of n minus log base b of n, and then if we have a power, we can bring it out front. Now, sometimes you want to go from this side to this side, sometimes you want to go from this side to this side. In our next example here, we want to condense this using the multiplication rule. So this was the same as log 4 of x plus 4 times x minus 1. Don't be tempted to add. Okay, so now I have log of something equals log of something, so the insides must be the same. So when I FOIL this, we get x squared minus x plus 4, so plus 3x minus 4 is 2x plus 8. Okay, we have a trinomial that we want to factor, so I'm going to move everything to one side. So x plus x, 4 minus 8 is minus 12. So this is going to be x plus 4, x minus 3. So either x equals negative 4, x equals 3. Algebraically, those are both solutions. However, if I plug a negative into those, we're taking the log of a negative value. So the correct answer is x equals 3. Okay, to find the inverse, just like we did before, we're going to switch x and y and solve for y. So we'll add 1. Divide by 2. Okay, so to get rid of log, I'm going to raise both sides to the e. I'm going to go over here. So e to the x plus 1 over 2 is going to equal y plus 4, because if I have e raised to the natural log, it goes away. So my inverse is going to be e x plus 1 over 2 minus 4. This one, x equals 2 y minus 7. We'll divide by 2. Okay, this time we're going to take the natural log of both sides. Because if I take the natural log of that, all I'm left with is y minus 7. So my inverse is going to be the natural log, x over 2 plus 7. Okay, next we have graphs. So 2 to the x, just as a reminder, is 0, 1, 1, 2, 2, 4. Looks like this. So 2 to the x minus 3 is going to move the graph to the right 3. So this is going to go here. So this graph will look like this. Again, this is multiple choice, so you just need to arrive at the right answer. Natural log. Natural log of 1 is 0. Natural log of e is 1, and e is about 2.718. So natural log for us is here at about 2.718. It's at 1. And really, you're just looking for multiple choice. Do you know what natural log looks like? It's going to be asymptotic at 0. We can't take the log of 0 or negative values. So that is natural log. All right, for Unit 4, our trig unit, the first questions are asking to solve the equation for 0 to 360. So remember that our cosine is the x-coordinate on the unit circle, sine is the y-coordinate on the unit circle, and tangent is y over x. So for your, you're going to be given a unit circle for your cheat sheet. So what I would suggest doing is marking a couple of things on here. I would go ahead and mark your tangent values so that if you're asked it, it's already done. So tangents 0 here, root 3 over 3 here, 1, root 3, undefined, and then it's just going to reflect over. So in the fourth quadrant, this is negative root 3 over 3, negative 1, negative root 3, undefined. Second quadrant, negative root 3, negative 1, negative root 3 over 3, 0. And then in this quadrant, it's the same ones, but positive. Okay, so we have that. So here, where is cosine, where are x values equal to 0? Well, that's going to be here at 90 degrees and here at 270 degrees. Tangent equals 1. Well, we already labeled it. 45 and 5 pi over 4. Or, but in degrees, 45 and 225. Our sine, our y, being negative root 3 over 2, is going to be here and here. So 240 and 300. For the inverse functions, remember that the range is the important part. For sine, it's from negative pi over 2 to pi over 2. Cosine is from 0 to pi, and then tangent is negative pi over 2 to pi over 2. So on your unit circle, you might do something like this for sine, cosine, tangent. But remember that when we did this, we changed some of this. So you might add something like inverse function in a different color, where this is going to be 0, this is negative pi over 6, not 11 pi over 6, this is negative pi over 4, this is negative pi over 3, this is negative pi over 2, and so on. So here, where is sine inverse equal to negative 1/2? So you're looking for the y value on this half, so that's going to be right here, but since it's the function, it's not 11 pi over 6, it's negative pi over 6. And then we're taking the tangent at that same location. So turn right back around, negative root 3 over 3. Cosine inverse of negative root 3 over 3. Okay, so that's going to be right here at 5 pi over 6. And then tangent inverse of negative root 3 over 3. So that's on this half of the circle. Negative root 3 over 3 is negative pi over 6. Next we get to graphing. So in the free response video, I went through all the different rules for identifying from the function amplitude, period, phase shift, and vertical shift. The amplitude of this one is 2. The period is going to be 2 pi over b, which is 1. My phase shift is negative c over b, so negative pi over 4 over 1, so that'll be pi over 4. And then my vertical shift is going to be 5. Here, amplitude is 1, period is 2 pi over b, which in this case is 1/2. So that's going to be 4 pi. Our phase shift is negative pi over 3 over 1/2, which is negative pi over 3 times 2 over 1. So negative 2 pi over 3. Our vertical shift is 0. Okay, now we're going to write an equation. We're going backwards. Sine function, amplitude of 4, period of pi over 2, and a phase shift of pi. So my A is going to be 4. My B is going to be 2 pi divided by pi over 2. So that's going to be 4. And then a phase shift of pi. So C, our phase shift, which is pi, equals negative c over b, which we just found. So my c is going to be negative 4 pi. And then we'll put this all together in an equation. So y equals 4 sine, my b was 4, my c is negative 4 pi. Okay, and then this next one, we're going to write the equation with sine, and then we're going to do a cosine. So sine's pretty straightforward. Our amplitude is 1. The period is pi. So my b is going to be 2 pi over pi, or 2. So this one's just going to be y equals sine 2x. To make this a cosine, my phase shift is going to be this location. So if this is pi over 2, this is pi over 4. So I have a phase shift of pi over 4. These two things remain the same. The amplitude and period, we've just shifted it over. So pi over 2 equals negative c over b. So if I multiply over 2, my c is going to be negative, this is negative pi over 4. Pi over 4. So if I multiply this, this will be 2 pi over 4, or pi over 2, and it's negative. So this will be y equals sine 2x minus pi over 2. Okay, so we're going to find the area. So we have two different formulas for area. This one we use when we have side, angle, side. This one we use when you have side, side, side. Okay, so this first one, A is 15, B is 12, C is 9. So this is side, angle, side. So we're going to use this formula. A and B are the sides. C is the sine. So this is the calculator allowed. Your calculator should be in degree mode for this. So this will be 1/2 12 times 9 sine 15. Type all that in your calculator and you'll get 14.0. This one, we have side, side, side. So we're going to be using this formula. Okay, S is the subperimeter, is going to be 1/2 25 plus 30 plus 23, which ends up being 39. So my area is the square root of 39, 39 minus 25, 39 minus 30, 39 minus 23, which is 280.4 units squared. The remaining questions all are law of sines and law of cosines. So we use the law of sines when we have angle, angle, side, angle, side, angle after solving for the third angle, and then side, side, angle. But remember, this one is the ambiguous case. So if we have this, we need to figure out if there are 0, 1, or 2 triangles. Law of cosines we'll use in SAS, SSS. Okay, so I find it helpful to draw the triangle. Now this is a clue. How many triangles are there? So this is going to be the ambiguous case. So A is 66, side A is 14, B is 11. So we start with the law of sines. Okay, cross multiply, divide by 11. And then B is going to be the sine inverse of 14 sine 66 over 11. So either you're going to get an answer or not. In this case, we will, and it's going to be 45.9. So we have at least one, but there could be a second. The obtuse possibility, because there could be that, is going to be 180 minus the 45.9, which is 134.1. Can 134.1 and 66 be in the same triangle? No, they cannot. It is bigger than 180, so there is one triangle for this. Next one has the same conditions. We've got angle, side, side, which is our ambiguous case. So how many triangles? So we'll do sine 38 over 8 equals sine B over 10. The same algebra that we did before will lead to B equals the sine inverse of 10 sine 38 over 8. When we put that in the calculator, you get 50.3. So again, we have at least one. There may be a second. So we're going to check out our obtuse possibility. So that's going to be 180 minus 50.3, which is 129.7. So does 129.7 play nice with 38? And yes, it does. It is less than 180. So there's going to be two triangles here. Then our third one, You might be able to tell just because of these numbers, but let's go ahead and do the math. So sine 108 over 15 is equal to sine of b over 36. B then is equal to the sine inverse 36 sine 108 over 15. And you get error, which means there is no triangle. Next, we're going to solve triangles. So this first one here, we're going to solve, I've already put the information in our triangle, and when we're solving, we need to find everything. So here we have SAS, which means we're going to use the law of cosines. Okay, so I'm going to find a squared equals 10 squared plus 2 squared minus 2 times 10 times 2 cosine 31. When you do all of this and then the square root, you get 8.3. Okay, we always want to leave the biggest one for last. This is last, because it could be obtuse, and when we do this law of sines, we may not get the right answer. So b over 2. So b is the sine inverse of 2 sine 31 over 8.3, which gives us 7.1. So my last angle is going to be 141.9. So had we done that in the calculator with the law of sines, we would not have gotten that as an answer. All right, the last one. Here's all our information. This one is going to be last. This one we're going to use the law of cosines to find the angle. So let's start with A. So if I'm finding angle A, then 12 needs to be on this side of the law of cosines. Okay, then to algebraically solve for this, we subtract these two. Then we'll divide by this. And then we will take the cosine inverse. Okay, so when you do this in the calculator, you get 24.1. Next step then would be to use the law of sines to find b. We'll use our newfound 24.1 with the 12, sine b over 15. So 15 sine 24.1 over 12 gives us 30.7 for b. So my last one, which again is obtuse, is 125.2. So these are the questions that you can expect to be on your pre-calculus final. Good luck.